Alright, welcome back. In this video, we're going to look specifically at some concepts of angles and triangles. Now, most of the time, most students are responsible for having to memorize these different figures and ideas, as well as how to name them. So one of the things you want to make sure that you pay attention to, especially if you are in a course, is that you know exactly what is being required of you. Okay, so we've got a bunch of basic figures, and so what we're going to do to start with is we are going to look at how to name these different figures as well as what these figures look like. So first and foremost, we have what's called a plane. A plane is a flat surface that extends in all directions. We label it with a capital letter. So capital P here, usually placed near one of the corners. And so when we go to name it, we would have to name it by saying that this is plane P. Now, an example of a plane would be something like a wall, a road, etc., where we are talking about flat surfaces that are extending in all directions. Now, the reason why things like a wall might qualify is because wall, the definition in general, is just simply a standing object. And so we have no idea how tall or wide a particular wall may be. They can be all shapes and sizes, and thus that fits your definition here. Now the next thing we have is called a point. So obviously it would be a singular point. Again, we denote them with a capital letter that is written kind of right next to your point. And when you go to name it, it's very simply named point A in this case. A ray is a figure that starts at a point and it extends out in one direction. So notice I'm starting at a point, but I have this arrow on the end. I'm going through my point Q, but I've got this arrow signifying that I'm going to continue on going. When we look at a ray, we usually have a start and a what I like to call the pause point. It allows you to identify what is going on. And so when we go to name this, we would name this as ray. And then the ray is going to go PQ, so we're going to use our capital P, capital Q. Above that, we have to signify an arrow, and we're signifying it in the direction that it goes. So we're starting at P and going through Q. So we start at P going through Q. And then we have to signify that you have the end point at P. So labeling a ray is a little bit more specific than it was when we labeled our planes or our points, in that we have to identify not only direction but what the ending point was. Now, how that differs from a line is a line will go forever in either direction. And so here our lines can be labeled in two ways. First, we could label the line in general with a lowercase letter, so lowercase l, for example. Or we can have two individual points within that line, so say the points A, B, and label it that way. So first and foremost, we could label it based on the line in general, so we would say that we have line L. Or you could say that we have your line. We would use the points A, B, but then we would draw an arrow going in both directions above it, signifying that you're going through B as well as through point A, and continuing on forever. Okay. Now, the last figure that I wanted to look at here is what it means to have an angle. So an angle is anything where essentially you have either a line that's been bent, or you consider it as two rays coming out from a single place. When we label it using your 3 points in general. And so here you would start at 1. So say for example we would start at A, so we would go from A down to C down to B. And so in this case we use the angle sign, so it's kind of like this almost like a greater than less than sign. But you're going to use your little angle sign, and then you're going to write it. So this went from A to C to B. Essentially you're playing connect the dots. And then usually we would specify that you have your vertex is at, say, point C. Now the vertex is that point at which you have the actual angle here. That would be the vertex of your angle. The other way that you can remember vertex is it would be, say, the point at which your line was bent, or where it folds. And so that's how we label an angle figure. Now we can classify many different types of angles. So first of all, we have what's called a right angle. So you can see this picture over here. We have this right angle. We've got this fun little square down in the bottom. And notice the little square, or this angle here, is what is being labeled. And so here we would call this angle A. And if we want to know the measure, we would say that the measure of angle A is 90 degrees. Okay, so M stands for measure. The similar looking less than greater than sign stands for the angle. A is the label of the angle. Now again, when we're talking about a straight line, it would be as if we took an angle and just laid it flat. We've labeled it as angle B, which means B right here would be its vertex. And when we're talking about what's called straight angles or straight lines, we have that the measure of angle B is 180 degrees. Okay, laying completely flat is 180 degrees. Now, when we talk about acute, I like to remember it like this, that we have a acute little angle. Acute means small. In other words, it means less than 90 degrees. And in this case, when we talk about how it's measured, we would state that this goes from 0 degrees through to the measure of angle C, which is less than 90 degrees. So you can see that that's exactly what's going on here. That we've got our angle, and it falls between 0 and 90. Now, an obtuse angle is a large angle. It is normally greater than 90 degrees. But at the same time, it is going to be less than 180 degrees. So here we would have from 90 degrees up to the measure of angle D, which is less than 180 degrees. Now, a complementary angle is two angles whose sum is 90 degrees. And when we talk about supplementary angles, we are talking about two angles whose sum is 180 degrees. Okay, so for example, when we're looking at complementary, we may have, say, this 90 degree idea here. but we've got this thing cut, and so here we've got this first angle that we may call, you know, A, B, maybe this is angle D, which would mean that this angle here might be angle C. And so what we're looking at is we would have, say, angle ADB plus angle BDC has to give me 90 degrees. So that's kind of what we're looking at. It's the same concept when we're dealing with supplementary angles, in that there are 180 degrees. So one thing that you might be asked to do is you might just be asked to classify an angle. And what that means is that you are given essentially a picture and you just simply have to label it. So when you look at this picture, what you need to remember is this kind of looks like a lounge chair. When you have something that looks like a lounge chair or a reclining chair, this is considered to be an obtuse angle. Now, anything that looks like you have a wall standing on a floor, this would of course give you that this is a right angle. Now, another problem that you may see says that you need to find both the complement and the supplement of the given angle. So what this means is, do you remember your definitions? So again, when we're talking about complement, we are talking about that you are going to sum to 90 degrees. So therefore, in this case, we have x degrees plus your 56 has to equal the 90 degrees. If you move that 56, what you're going to end up getting here is that your x is going to equal 34 degrees. Now that being said, when we're talking about your supplement, again, we are talking about that you sum to 180 degrees. So in the same thing, now you're going to have your x plus your 56 degrees has to equal 180. Therefore, when you solve for x, you come out with x is going to be 124 degrees. So one of the takeaways that you can have here is that complementary angles are acute angles. They are small. Whereas supplementary angles, you're going to have one acute and one obtuse. Okay. Now, another thing that you may be asked to do is you may be given a bunch of angles and you may be asked to identify types. So first of all, this is telling you that DC, so this line right here from D to C, is a straight line. So that would tell me right away that this is 180 degrees. The second thing that you're being told is that angle BOA, so BOA is 90 degrees, which means this angle right here has that really cool looking box that generally gets put into it, but it's 90 degrees. Now, the biggest thing that you need to do when you're working with these types of problems is answer the question being asked. These problems are designed to give you a lot more than what you necessarily need. Here, the first question wants to know what type of angle is AOC. So the first thing that we are looking at, okay, so we're looking at this first question here, which means we're looking at A down to O over to C. So this is the angle that we are paying attention to. And all it wants to know is the type of angle that you see. Well, the stuff here in yellow kind of looks like a lounge chair to me. Therefore, its type would be obtuse. Notice I did not ask in any way, shape, or form what the measures were, just what classification of angle it is. Now the second question says, what type of angle is BOC? So here, if we look at what type of angle is BOC, we have from B down to O over to C. So this angle here. So if we look at this green angle, notice it looks like a cute tiny little angle. Therefore we call it acute. Now with that particular problem, that's all you were asked. Which means this information that was given about the fact that this angle here was 90 degrees is theoretically unnecessary information for you to answer your problem. So you have to pay very close attention to the question being asked and the information being presented. Now the other classifications that we have to deal with types of lines. So we have lines, but then we also have what are called special angles. First and foremost, we have three types of lines: intersecting, parallel, and perpendicular. Intersecting is just that, lines that cross each other. Parallel are two lines or more that will never cross each other. They run next to each other. And then perpendicular are lines that cross, but when they cross at 90-degree angles. Now, in terms of our angles, we have two very special cases here. The first is vertical angles. Vertical angles are formed when you have intersecting lines, so you're looking specifically at angles opposite each other. Usually these angles have to be equal to each other. When we talk about adjacent angles, we're talking about neighbors, angles that share a common side. So how does all of this come into play? Well, in an example like this one. Here we want to use the definitions of your adjacent and vertical angles and using the figure below to answer your questions. So first and foremost, we have angles 1, 2, 3, and 4. So question 1 says, if the measure of angle 1 is 30 degrees, then what is the measure of angle 4? So here we are looking at angle 1, and we are saying that this is 30 degrees. The measure of angle 4 is directly down here. Notice these two angles only share a point. What that means is that angle 1 and angle 4 are vertical. Therefore, the measure of angle 4 is also 30 degrees. So that makes this one 30 degrees. Now the second question says find the measure of angle 3. So if we look at, say, angle 1 and angle 3, what do we know? Well, we know that angle 1 and angle 3 are adjacent. We also know that they make a supplement, because this is clearly a straight line, and the supplement means two angles that add to 180. So to find the measure of angle 3, we simply know that we have x plus my 30 has to equal the 180 degrees, which means the measure of angle 3 is going to be 150 degrees. Now the third question says to name a pair of adjacent angles. So we've already done that. We have angles 1 and angle 3. However, we've got more than one. We also could have said angle 3 and angle 4. We could have said angle 4 and angle 2. Or we could have said angle 1 and angle 2. Okay, so all of those pairs would have been acceptable solutions for adjacent angles. Now when we're talking about vertical angles, again, remember we're talking about angles that share a point. So here we already looked at the fact that angle 1 and angle 4 were vertical in the beginning. But the other pair we could have looked at was angle 3 and angle 2 being vertical. So when you're answering these questions, you need to make sure that you are looking at the whole. And you look at the whole in reference to the definitions needed for your questions. And then only answer what you have been asked. Now the very last fun thing that we can do is we can play around with triangles. And one of the things that we like to do with triangles is we again like to classify them. The biggest thing to remember about triangles is that the sum of the angles in a triangle is 180 degrees. Period. Never changing. Now, we have a couple different ways that we can classify them. First, we can classify them by their sides. We have what's called scaling, isosceles, or equilateral. Scaling means none of your sides are equal. All three of them are completely different. Isosceles means you have two equal sides, at least. And equilateral means all three sides are the same. Now in geometry, these little tick marks here are what signify that you have identical sides. So here we're saying that these two sides are the same, but this bottom is different. And in this other one, we're claiming that all three sides are the same. Now the other thing that we have that we can classify by is by your angles. So in this case, we would have what's called acute. Acute says that all three angles are less than 90. So here, all three angles are less than 90 degrees. A right angle says that you have one right angle. It also says that the other two angles are less than 90 degrees. An obtuse triangle says that you have one angle greater than 90 degrees and two angles less than 90 degrees. Okay, that's what forms an obtuse. So with that, you may be given questions or may see questions where you're just simply asked to classify the triangle by sides and angles. So what that means is you are looking to classify one from each category. So if you look at this first triangle, the first place that thing that I would classify it by is its angles. Notice all three angles appear to be less than 90, therefore we would classify this as being acute. The second place that I would classify it is if you look very closely, it is clear that two of these sides at least appear to be the same. Therefore, we could also classify this as isosceles. classified by angle, classified by side. Looking at the second example, again, if you look at by angle, I have two angles here that are clearly less than 90, but this third looks like 90. Therefore, I would classify this as a right angle. And then if you look at all three of these sides, they all appear to be completely different, making this scaling. The last one says to find the missing angle measure. So this angle up here is the one that's missing, and I would classify this as a right angle, meaning this one is 90 degrees. Okay. Therefore, in order to find the missing angle, we have to remember that all should add up to 180. So my x degrees plus the 43 degrees plus your 90 should all equal 180 degrees. Therefore, the missing angle should be 47 degrees. So that should be everything you need to know in a nutshell to get started at using angles and triangles, as well as classifying figures. I hope you enjoyed what you saw, and if you have any questions, please be sure to let me know. Otherwise, sit back, relax, be creative, apply your definitions, and I'll see you next time.